Hi guys, today we're doing section 8.4, how to solve word problems using systems of equations. Okay, you're doing page 377, number 1 through 16. Let's say it's to tomorrow night, 6 p.m.-ish. That is for period 1 through 5, and for period 2 and 4, we can say Monday morning. I would highly suggest you do it on the day that I assign it. There is tutoring today on Friday at 2:30 to 3:30 if you are struggling. Okay? Friday, 2:30 to 3:30. All right, let's get started. Number 1 through 3 in your homework, you're really not going to need to use the box method. I'm going to be teaching you something with boxes, and you're not going to need to use it. You can just translate your equations. 4 through 7, on the age problems, we use the boxes to organize our information, not solve it. And then 8 through 16, I actually use them to solve these problems. And so when I say you're doing 1 through 16, I want you to attempt as many as you can. If you are struggling, remember we will go through it at tutoring, and we will also go through it on Monday. Okay, let's go. So let's not write this one. We're just going to talk about this one. So Marty has $45 and is saving $2 a week. Wayne has $12 and is saving $5 a week. Write the linear equation to represent each person's savings and graph. Now, tonight you're not graphing at all, but I want to take a minute to just show you that section 8.1, what it looks like, okay? So the first thing you have to do is you have to identify what is the independent and the dependent. So in this word problem, we have two things that are unknown. We have two things that are varying. And that is the things that vary, as in variable. We have our total savings varies, and the number of weeks vary. So how you figure out which one is the X and which one is the Y, the depender is always the Y. The depender is always the Y. Okay, so if we're talking savings, because those are our two unknowns, Wayne has 12. We really want to know the total amount in the account, and he's saving $2 per week, number of weeks, right? So what we want to know is the savings depend on the time, or does the time depend on the savings? So really our savings, it depends on how long we go. If we go for 2 weeks, we only have a little savings. If we go for 4 weeks, we have more savings. So our savings is the depender. That means that is the Y, and the independent is the X. I always determine my independent by just looking at the situation and trying to figure out what is the depender in that relationship. So now that we have that, we can write our equation. So we've got two different equations here. Okay. We've got Marty and we have Wayne. Okay, whoops. And so remember, we are going to be writing this in the Y equals mx plus b, or Y equals b plus mx. It doesn't really matter. But really what we're kind of looking for is that savings, right? Because that's what Y represent. Our savings is equal to our starting amount plus our weekly amount. The money times the weeks, right? So really this would end up being Y equals our starting amount for Marty is $45. It's our, and then we have plus $2 per X week. Okay, I want you to pause that. And now you try it for Wayne. Try it for finding the equation for Wayne. Now check your work. So hopefully you got Y equals 12 plus 5X. Okay, the last part of it, it said write the linear equation that represents each person's savings. So it shows Marty's savings and it shows Wayne's savings. Now it says, and graph. So we take that equation, and I'm going to remind you with our x's, we choose our x's. We choose our x's. So we could start with 0 weeks. Remember, x represents our weeks, y is our savings. So at 0 weeks, if I substitute that in, right, we end up with 45. If I have 2 weeks, 2 times 2, basically that's 4 plus 45, it's 49. And we can keep going on and on. If I have 4 weeks, 45 plus 2 times 4, that is 45 plus 8, that is 53, and so on, okay? So I'm going to plot those. And then when I make my graph, remember the x-axis has a name, and your graph means nothing unless you write the name of that axis. So my x-axis, again, we already have named it. The x-axis is weeks, and the y-axis represents savings. Now notice your x goes from 0 to 12, so it has to include those numbers, but your y goes all the way up to almost 70. So I'm going to go by 5s or by 10s. I'm really going by 5s because every other line, right? This is 5, that's 10, this is 15. So we're really increasing by 5s. And now I'm ready to graph each point. 0 across, 45 up. 2 across, 49 up. 4 across, 53 up, and so on. And I draw my line. Notice the arrow on the end of it. It goes on and on in this pattern. Now, I'm going to do the next one, same thing. We're going to choose our x's. We're going to substitute those into the equation, and we get the following numbers. And then I'm going to plot those points. And now, the real thing to look at here is, what is the solution to this system? What is the solution? We've been talking about solutions, and my solution is this point right here. It's this point. And so I'm going to kind of estimate it. Okay? And so if I were making an ordered pair, we know that it's about 11 across. It reaches 11 on the x-axis. And then it goes up to almost, I don't know, 68, something like that. And that represents 11 weeks and $68 savings, right? $68. But it's not very exact. Okay, it's not very exact. So hold on to that thought. Now, if this was an investment, and you were asked, who would you want to follow? Okay, we've got our first one up here. This is Marty, and this is Wayne. If this were your money and you were investing, I think the question that I would end up asking is, it depends on how long I'm investing for. Because if I'm investing for less than 11 weeks, for even up to 10 weeks, I likely would be following Marty. But anything after that 10 weeks or 11 weeks, I'm really going to want to follow Wayne, because clearly he's making more money if we continue on that same slope. So our graphs really help us to predict future decisions. But now, like I said to you, that solution there is in the middle of 2 boxes. It's not very exact. So for that reason, we don't like to graph, right? We don't like to graph to find a solution. So since you have your 2 equations and one variable is already alone, I'm going to use my substitution method because I'm already set up to kind of do substitution. So I just set them both equal to each other. Substitute the 45 plus 2x in for y, and now we've got 45 plus 2x equals 12x. Let's get our x's together. I'm going to subtract 2x on both sides. And now I'm going to subtract 12 on both sides of the equation. Now we're left with 33 equals 3x. I'm dividing both sides by 3, and we get x equals 11 as was predicted, as was what we saw. Now, we kind of guessed that our savings was about $68, so let's see the exact amount. I personally, you can choose either original equation. I'm going to choose this one right here, y equals 12 plus 5x. And I'm going to substitute in. We know that x equals 11, so I'm now going to be substituting it in here. 5 times 11, and so we get y equals 12 plus 55. When I add that up, I actually get to 67. And remember, y represented our savings, so it's $67. So at 11 weeks, they both save $67. Okay? At 11 weeks, they both save $67. So this substitution and elimination method are far more accurate, because we can't exactly see, we can only estimate when it's in between boxes. And the same thing came up when I was checking the graphs on your tests. And remember, I can't grade numbers that are not whole number points because I have to estimate it. We're going to skip this one right now. We can come back to it. Okay, let's try another one. So, we have Warren High School has 3,000 students and is increasing at 250 students per year. Downey High has 5,500 students and is decreasing at 100 students per year. Write a linear equation to represent the population of each school and graph. So what is varying, what's changing is our population and students per year, or the years, right? So we really have to kind of decide, which is the dependent. Is the population dependent on the year? Is the year dependent on the population? Does the year depend on the population? So really, our population depends on the year. And my hint to you is that time is usually your x, your independent, but here the quantity we had at the school depends on the year, okay? So we're going to start with our x is equal to the year, and our y is the population. So I want you to pause the recording and see if you can come up with these two equations. Now let's check our work. For Warren, we have y equals, our base amount was, our starting amount was 3,000 plus 250x. And for Downey, hopefully you got, y equals 5,500 plus 100x. Now if you had written that y equals 250x plus 3,000, that's correct too. Doesn't have to be like, you can have it in slope-intercept form. All right, so now they're wanting us to do the same thing, graph. We make a table, we choose our x's, we get our y's, and we're basically doing the same thing. So here it's even more difficult to figure out what the solution is, because it's really at the intersection of a couple of boxes here. So we can guess it's 7.3, 7.2 is the x, and the y is, I don't know, 4,600. Well, that's why we go to substitution. Okay. So we're going to do the same thing. Y is alone. It doesn't matter which one you do. I could take this and substitute here, or I could go take 3,000 plus 250x and substitute there. And now I'm going to get my x's alone. Shh. And now, sorry, I'm dividing by 350. And then I get x is about equal to 7.1. I can figure out the y. They're not asking us for it, but Shh. Y equals 5,500. You know what, I'm going to need a little more room there. Let's go right over here. Y equals 5,500 minus 100 times 7 1/10. Y equals 5,500 minus 710. We get Y is equal to 4790. So that means, going back to our original story, that it's 7 1/10 weeks. I'm sorry, 7.1 years, not weeks, years. The population was 4,790 students, and that is at both schools. Remember, at both schools. So that is our solution. All right, now I want you to start writing this. Please pause the recording and write the question. Okay, now we're going to use the boxes here to organize our work. So we have Jan is 16 years older than Barbara is now. In 4 years, the sum of their ages will be 50. How old is each now? So the first thing we're going to do is whatever we're comparing, we're going to put on the left side. Okay, whatever we're comparing, we're going to put on the left side. So here we're comparing Jan and Barbara. Jan and Barbara. Now, also what we talk about is 2 different time periods. So in the first time period, we say, they're talking about now. So in the first time period, we're doing now. And then we also talk about in 4 years. So when we see Jan now, we can call her X, but I don't like to do that. I like to call her by her variable, the starting variable of her name. So I'm going to call her J. Oops, I'm going to go back. Let's call her J. And we'll call Barbara B. All right, now, the age in 4 years, okay? Jan's age in 4 years will be J plus 4. And Barb will be B plus 4. Now we're ready to start translating. So when we see Jan, we write the letter J. Okay? Is, was, will be means equals. And now we have 16 older than, and we have that than Barb. Well, that's a B. This is a 16, and older than is this, is plus. But because it says than, we have to crisscross our terms. The 16 is on this side, the B is on this side, the plus sign here. So it's really going to be B plus 16 because it has that word than. Whenever we see than. Okay? It's not mattering as much with the plus, but I want you guys habitual about this so that when it does say less than, you remember to cross your terms. And it's saying Jan is 16. We're using J and B because it says now. Now, the period, you have to pay attention to your punctuation because the period says, okay, equation's over. Now we have in 4 years. In 4 years. That means for the whole sentence, comma. This is anything they're talking about, anyone they're talking about in 4 years. We're gonna call them by their name in 4 years. So it says the sum of their ages. That means to add. Okay. Jan's age in 4 years is J plus 4. The sum of their ages. Barb's age, B plus 4. Will be, there's my equal sign, 50. And those are our 2 equations. So we are going to, now we're also still set up for substitution. So I'm going to take this and substitute in. So I get B plus 16. And then I've got my plus 4 plus b plus 4 equals 50. So I've got 2b, and then positive 16 and 4 is 20, plus 4 is 24 equals 50. I'm subtracting 24. I get 2b equals 26, divide by 2, and b equals 13. Okay, b equals 13. So if b is 13, I place it in here, 13 years old. Barb is 13. And now I go back to my original equation, either original. J equals, b is 13, so 13 plus 16. J is equal to 29. So Jan is 29 years old. And Barb is 13 years old. So I use these boxes not to solve, but to just organize my information. So with the age problems, I just organize my information. All right, you can pause it and take notes. Okay, I don't like to use X and Y because when I find my answer Y, I don't know who I'm talking about. When I get B equals, I know I'm talking about Barb. So I really use the letter of the person's name. All right, pause the recording, try the next one on your own. So we're going to compare Mary and Sarah. And then in the top, we're talking about now. And then we're also talking about 5 years ago. So let's call Mary M and Sarah S. I use the handwritten S because otherwise it looks like a 5. And we're doing M minus 5 and S minus 5. And now we're ready to go. Mary is 18 older than Sarah. Hopefully you came up with M equals S plus 18. And 5 years ago, Mary, okay, this is the whole sentence 5 years ago. 5 years ago, Mary, it would be M minus 5. Was, is, was, will be is my equal sign. Twice as old as Sarah. Remember, 5 years ago. Twice as old as Sarah 5 years ago. So that would be Sarah is S minus 5. 5 years ago, that's her great age. And now we can do our substitution. Substitute in. I'm going to get S plus 18 minus 5 equals 2 times S minus 5. So I'm going to get S plus 13 equals 2S minus 10. S plus 13. Oh, I'm not doing anything. I'm so tired. It's the end of the day. I'm going to subtract S. I end up with 13 equals S minus 10. Add 10, add 10. 23 is equal to Sarah. Now, I want to emphasize, I know logically you might be figuring this out, but our equations are going to get harder. So I need you to learn my method because we're going to build on this. I promise you this will make it easier. And eventually you'll be able to drop the boxes. So Sarah's 23. So if I substitute in 23 plus 18, Mary is equal to 41. So Mary is 41 years old. And Sarah is 23. Okay? Now again, remember they use X and Y, but I personally don't like to do that. I'm using M and S. All right. Okay, this is a big one, a very important kind of word problem that we're going to see over and over. take the time to at least write this question. Joe bought 15 items for $135. If the 15 items consisted of notebooks for $4.50 each and calculators for $12 each, how many of each did he buy? So we are going to create a 3 by 3. I usually make 3 rows of 3, but that's fine. You can start with this. I don't always use all my boxes, but I usually do like 9 boxes. So the first thing we do is we ask ourselves, what are we comparing? Okay. We have 2 different items, and the 2 items are notebooks and calculators. Those are the things we're comparing. We put them on the left. And now on the top, I like to call this amount. This is basically your quantity. Maybe your first time write quantity. I always write AMT. It's the amount. Sometimes I just put the number sign. And then we're going to multiply going across. And over here you write the units. Now here we're talking about money is the units. So we're going to multiply the amount times the money is equal to a product. Okay? We're going to multiply going across. That dot means to multiply, right? And we're going to add going up and down. We're going to get a sum going up and down and a product going across. Okay? So, do we know how many notebooks we have? Nope, doesn't tell us. Do we know how many calculators? It doesn't tell us. Do we know how many total items we bought? Yes, they're telling us we bought 15 items. So we don't know how many notebooks, so we call it N. And we don't know how many calculators, so we call it C. Okay? And the total quantity of both is 15. So notebooks plus calculators equals 15. Now the cost per notebook, our unit price, okay, per notebook is $4.50. $4.50. And the cost per calculator is 12. So we multiply across. Remember, we always write our coefficient, the number first. We're adding going up and down. And now, do we have a total cost? This would be total cost, and this is the total quantity. Okay, so my total cost would go in this box. All right, so let's go back. I really should keep that. Let's go back to mine. Okay, I'm going to just erase that part. So what we have here are our 2 equations. There's one equation, and here's another. So we have N plus C equals 15. And the other equation is 4 5/10 N plus 12C equals 135. So the easier number to cancel, to make the additive inverse, would be the calculators. So I'm going to take that first one and I'm going to multiply by negative 12. And my new equation is going to be negative 12n minus 12c equals negative 10 times 15 is 150, 2 times 15 is 30, so it's negative 180. Where the second problem is just going to stay the same. 4 5/10 n plus 12c equals 135, and they're positive. Now, when we have a positive and a negative, we subtract. So $12 minus $4 is $8, another 50 cents is 7. It's negative 750 n. These are canceling, and we are left with 180 minus 40 is 140, another 5. So it's negative 45. I'm going to divide by negative 7 5/10 Divide by -7 and 5/10, and you are definitely allowed to use a calculator tonight. And n is equal to 6. I don't want you to get caught up. So if my notebooks are $6 each, okay, I can go back to either original. So I've got n plus c equals 15. And I'm going to replace the n with 6 plus c equals 15. I'm subtracting 6, and c is equal to 9. So we have 6 notebooks. Now, very important here that you don't mix that up because it says how many of each did he buy. So don't just tell me 9 and 6. You have to tell me, I'm going to write it in blue. We're doing, we have 6 notebooks and 9 calculators. Okay, and that's what I should see in your answer column. All right. So that really is our lesson for today. That was quite a bit. We did quite a bit. So I decided to use elimination here because notice both the equations were in standard form. They both had the x and y on the same side, whereas on other ones, so at this point, you guys get to choose what method you want to use, okay? All right, we can pause. I didn't do this with the other kids, but let's just stop it here. I did go through number 2 and number 1 on the homework. You can just translate straight. So let me see if I can get out of here. I'm going to pause it. Okay, I've pulled up number 2 of the homework. And it says, use the sales receipt to the right and find the cost of a taco and a glass of milk. Let T be the cost of a taco. So T stands for taco. And M stands for milk. Okay. Write an expression that shows the sum of those two is 210. So that would be T plus M equals 210. Now it says write an expression for the cost of 2 tacos. How about 2T? Write an expression for the cost of 3 glasses of milk. 3M. Now write an equation that shows the total cost for 2 tacos and 3 glasses of milk is 2. So 2 tacos plus 3M is equal to $5.15. So we end up with T plus M equals 210. And then we also end up with 2T plus 3M equals $5.15. So again, I'm going to remind you, I think I might multiply this by -2. Makes things really easy. -2T minus 2M equals $2.10. Why don't you guys finish that up, actually? I think I've done enough for you. I helped you to set it up. Now, do the best you can. What you can't do, come to tutoring. Or we will also go over this on Monday. It's a 2-day lesson, okay? So I want you to at least attempt some of the problems. If you wait till the weekend, then you will not remember how to do any of these. So it is best for you to do the work today, the day that you're learning it, okay? And that is our lesson.